There it is. Okay, so yesterday or Friday when I wasn't here, you learned the idea of proportional and not proportional. So when you're looking at that first one, what are you supposed to do so you can figure that out? Ashton?
So you have to put y over x and then it's
Very good.
Y over x first is 0 over 1. And I mean, you can't really simplify anything down to 0, so I would say it's not.
Okay, well, 0 over 1, if I give you 0 out of 1 on a test, you just got 0. I mean, that's just what you got. Okay, and then if I do the next one would be 6 over 2. That is 3. So it's already not proportional because those two aren't the same. Every single one has to be the same. So if I kept going, this would be 12 over 3, which is 4. Still not the same. 18 over 4 would be 9 over 2. Still not the same. No, this is not proportional. Okay, all of them have to be the same when you reduce them in order for them to be proportional. And you do have to use y over x. As we go through this longer, you will understand why it's y over x. This is such an important concept to Algebra 1. We will do this so much next year that you're going to want to puke a little on the inside, just like me on Friday. Okay, so lots and lots and lots. Lots and lots and lots of this. Okay, me puking. Right? Yeah.
Oh, that's why you weren't here.
Yeah, I left the note.
Oh,
Yeah.
I get it.
Yes.
You didn't leave a note.
I did leave a note. Yes. Yes.
Sometimes during class we can show us our averages.
Yes, I got that on number 3. Yep.
Oh, number 3.
All right. Circle the ratios that are proportional. So 27 over 9 would reduce to 3. So basically, as you look through those, you want all of the ones that would reduce to 3. 9 over 3, 6 over 2, 3 over 1, 54 over 18. All of those would have the same thing. That would be proportional. Okay, so here's a place and time in life where we actually use proportional relationships. This is actually posted somewhere on some fancy document. But Park Hill has ratios of students to teachers. Elementary school is something like 1 to 21 or 1 to 19. I don't remember what it is. And then as you get older, the ratio changes. So I think my ratio is 1 to 30 or 1 to 31. I don't remember what it is. Which means as long as the whole school balances out to 1 teacher per that many students, we're fine. If it doesn't, then they hire more teachers. So when you're looking at this one, you should go to this one right here and figure out what the ratio is. So 75 to 5, which is 15 to 1, which would be a pretty amazing ratio. So then I use that to figure out the other one. So if I have 3 teachers, how many students can I have?
45.
45. Because if I have 45 over 3, that is still 15 to 1. Okay? So if I have 120 students, how many teachers do I need? 8. So it's still 120 over 8, which is 15 to 1. If I have 10 teachers, how many students do I need?
150.
150, which is 150 over 10, which is still 15 to 1. Okay? All right. Is there anything on here that you don't understand? Yes.
Why does it have to be y over x?
Like I said, as we go through this more, I will be showing you examples of. The rest of topic 8 shows you some more examples of why it's y over x. Okay. All right. Okay, so learning goal today, the student will understand proportional relationships with graphs. So we're going to move from the tables to the graphs. Yes?
The one that's 1 over 15, will they always be the same on the row?
All of your ratios have to be the same if they're proportional. Yes. All right, so starting here, it says a graph can be used to show a proportional relationship between 2 quantities. So this is what you did on Friday where you had a graph, and I always put y over x, this would be x, this would be y, because in science, this would still be called your what?
Variable.
Your variable, and which one would that be? The what? Yes, and what would this one be? Dependent variable. Okay, so it's the exact same as it is in science. So what you would do is you would put 6 over 4. 6 over 4 reduces to?
2.5.
No. 3 over 2. Okay, 9 over 6 reduces to?
3 over 2.
3 over 2. 15 over 10?
3 over 2.
3 over 2. 18 over 12? 3 over 2. Okay. Now, we're going to keep it in fraction form. Again, you're not always going to understand why I'm doing this, but it will click at some point. You'll be like, oh, that's why she did it. Okay, now, then what they did is they showed you a graph of the same information. So if I would graph my time and heartbeats, so So this would mean my time is 4, my heartbeat is 6. That's where they graphed it. If at time 6, my heartbeat is now 9, 6, 9. Do you see how they graphed each one? We would expect this to continue to go up, right? Because if it didn't go up, what would that mean?
You're dying.
I'm dying, okay? So I would want this to increase. I would want it to increase steadily. If this says resting heart rate, right? It would be way different if I said take your resting heart rate and now everybody get up and do jumping jacks, because then that would change, right? But if you're just resting, your heartbeat should steadily beat and just keep going. So you should notice 2 things about this graph, okay? The first thing that's really important is that this graph is linear, okay? All proportional graphs have to be linear. They have to have that same rate, okay? The next thing this graph does is if it's proportional, it will always go through 0, 0. Yeah. I do.
I need her ready to leave.
Okay. All right, so 2 mega important things. Has to be linear, has to go through 0, 0. If those 2 things aren't there, the graph is not going to be proportional. Okay? Super important. All right, so let's look at some examples of graphs. All right, so look at these 3 graphs. Does each graph show a proportional relationship between x and y? So what do you guys think about graph A?
Yes.
Yeah. Yes, what were the 2 things I said?
Linear and 0, 0.
Linear and 0, 0. So this one works, yes. Why does the second one not work?
It
Doesn't
doesn't go through 0, 0.
Doesn't go through 0, 0. What about the third one?
Linear.
It's not linear. Very good. So this one does not work either. Okay? All right. Look at these next ones and tell me what you think about those. The first one is not. Why?
Because it doesn't go through 0, 0.
Because it doesn't go through 0, 0, so no. And this one's not linear. Okay, now, what's cool about this graph right here is actually half of a parabola, which we're going to learn about next year, and that's all the things that are x squareds. So this we will learn about in Algebra 1. Yes? What does linear mean? Yep. Yep.
Oh, because that one's linear, but it just doesn't start up.
Doesn't go through 0, 0.
Linear, but
Is this one proportional? Why?
because it's not linear.
Because it's not linear. It's not linear. Good. All right. Okay, so the next thing they want you to understand, which again is springboarding us into Algebra 1 stuff next year. We're going to see this a ton. Okay, so they asked the question, does the equation y equals 6x show a proportional relationship between x and y? So what I did is I went in and graphed it and then put a screenshot of this, because there's tons of graphing calculator apps online. And I said, okay, here's the table, and there's what the graph would look like. So again, I want you to see, because some of you have asked, why does y go over x? So let's look at this. What is 6 over 1?
6.
What is 12 over 2? What is 18 over 3? What is 24 over 4? Okay, so where is that? What happens up there?
6 over 6?
Isn't that what's in the equation?
Yeah.
So y equals 6x. So this would mean maybe I make $6 per hour. Okay, so if I work 1 hour, how much do I make?
$6.
2 hours I make.
$12.
3 hours I make.
$18.
Does that make sense? That's what it is in a table. This is what it would look like in a graph. Is this proportional? Yes, because it's linear,
And it goes through 0, 0.
and it goes through 0, 0. The reason I want to show you this one is it doesn't have to start somewhere, okay? It has to go through it. So if it goes through there, that's fine. Okay, does that make sense? And if some of you go, well, what does the negative mean? Maybe the negative means your brother did an hour babysitting. So now what happens? You owe him $6, or you just lost $6. And then your brother did it for 2 hours. Now you've lost $12. Okay. We can't talk about betting in school. Oh, we can? All right.
Why would you go into such a educational? It's not.
Okay, let's look at the next one. So here's this equation. Does the equation y equals 4x plus 1? Okay. Now, here's what it looks like as a table. Okay, so what is 5 over 1? What's 9 over 2? Not 5. What's 13 over 3? Not 5. Now, is this still linear? Yes, but what happened?
The equation is 0.
Okay, where does it go through, by the way? I still don't think I put it. Wrong. 0, 1. All you people who don't know your coordinate pairs. Okay, now, where do you see that in the equation? Where do you see that in the equation? In the middle? Where does it say it?
Oh, in the
Isn't it right there? Plus 1. What do you think would happen if they changed it to minus 2?
it would be just on the other side.
Where?
Like on the other side. Be a reflection.
No.
1, 0.
What if it said this?
Oh.
No.
Did we go through negative 2?
We go through negative 2. What if it was 4x plus 10? It would go through positive 10. If you say, well, how would that work in real life? This would, maybe I'd change the equation and say, I make $4 an hour babysitting, but I had $1 already in my pocket. And that would be the plus 1. I didn't start at 0 money. I started at $1. And then I increased.
So you babysitted for X hours and then you owed someone $2?
That's only if I go into the negative. Yeah. Yes. What? That is not proportional. And it's not proportional because it does not go through 0, 0. So just because it's straight doesn't mean it's going to be proportional. Yes?
So if any thing says like plus something or minus something, it's not proportional.
Correct. Okay, so now I want you to do this next slide, and I want you to answer all that question. So go ahead and answer that question. All right, tell me one of these that has a proportional relationship. James?
Y equals 3x.
Yep, A would definitely be one.
Y equals 8x.
Yes, that would be one. Rachel? And C. Okay, why is B not? Because it has a minus 2. Why is E not? Because it has a plus 4. Yes. How come Y equals X? Because there's nothing being added or subtracted to it. And Y equals X would be like you make $1 an hour is what that would stand for. Okay? All right. Now, let's look at if you can read a graph. Okay, so the graph shows a proportional relationship. It already tells us it's proportional, but we can tell it is because it's a straight line and it goes through 0, 0. Okay, so the first thing says, what does the point 1, 90 represent? What does that point mean?
1 hour 90.
James?
Every one time unit.
What is the time unit?
Seconds.
Seconds.
Every 1 second. Cheetah can run 90.
Very good. In 1 second, the cheetah can run 90 feet. That is fast, isn't it? Okay. All right. What? Next question. What does the point 0, 0 represent? Rachel? Very good. So at time 0, he hasn't gone anywhere. Poor cheetah. Okay. How far did the cheetah run in 3 seconds?
270 feet.
Okay, 270 feet. Okay, very good, right there. And assuming the cheetah continues to run at the same speed, how long would it take the cheetah to run 900 feet?
12 seconds.
12 seconds? Okay, great.
10 seconds.
10 seconds?
Yeah, 10 seconds.
Okay, now, I agree it's 10 seconds. Here's what we did last hour, because they wanted to know about that y over x. Could you write an equation for this? Yeah, what would the equation be?
991.
No. Think about what I showed you earlier, remember?
Y equals
Y equals x.
no 90x.
Y equals
90x.
10.
Good. 90x, because 90 is that number, that's that ratio. That's very good. And it's 1 to 90. So each time. So if I wanted to know 3, I could say 3 times 90 is 270.
Oh, because 10 times 90 is 90.
Yes, exactly. Okay? All right. What I want you guys to do next is I want you guys to go to the next 3 slides and make sure you can answer everything on the next 3 slides, and then we'll go over it real quick. Okay? Boxes. 100. Oh, I put 100 minutes. 100 boxes. Whoops. All right, very good.